Hi there, I'm Jeff. I'm a Senior Product Manager here at CloudNC, and today I'm going to introduce you to the Softjaw Designer function in the Canvas plugin. So why would you want to use a Softjaw? In a number of cases, when you're machining, you need a custom set of holders or fixtures for your part. So we've got a sample part here on screen, and it's got some features that'll help explain Softjaws. So if I load in my part with my fixture in mind, and I have it above the vise right now and above the soft jaws, the yellow bodies, I'm going to lower it into place and then position it. And then what I want to do is use those existing yellow bodies, my soft jaws, as something I'm going to machine to accommodate this part. So I'm going to come into the manufacturer space, and then I'll click on underneath the Cam Assist icon. I can click on the fixture management portion and Softjaw Designer. So now what I can do is pick my part. In that case, I'll pick the part. And I can pick my jaw geometry that I have there, those two yellow bodies. And then I'll pick the spindle direction, this will be from the top, and the opening direction from the side there. And then what the jaw geometry is going to be populated with is going to be blanked out in this case because we have geometry selected. So we're not going to enter that value, and we're going to run with our existing geometry. And same for the position. So we'll just leave those. And this has an interlocking features. So I'm going to make sure that is checked, interlock prevention. And the corner relief drill size, I'm going to set that to a little bit higher value than what's on the default. And then for the heights, I'm going to pick these 2 points. So it's a vertex selection for multi-level heights in the Softjaw Designer. So we'll click those two and then let run. So now it's generated our bodies. If we look in the body section, we'll see we've got the corner relief drill size showing up for those corners, and also the interlock. So those features are allowed to slide in and out as we clamp the jaw, and we can highlight those there. The bosses on the bottom, those two circular and one rectangular bosses, you can see how they would be able to slide in and out of that vise, or in and out of those soft jaws. And there you see the corner relief on the corner. So that's one example. So that was using existing bodies that we were making into a machinable soft jaw. We have another example here where we just have the part, and we're going to create the jaws in the Softjaw Designer itself. So we'll go to manufacturer space and pick our tool, the Softjaw Designer. In this case, we'll pick the part. We're going to not pick any jaws, but we will pick the spindle direction and opening direction settings. And click those faces. Now for the jaw geometry, I'm going to add in some values here to create our jaws. And I can define the gap, that's the distance between the jaws in the closed position. And the corner relief drill sides again, and all around clearance, I can leave. Typically that's going to be sort of, a few thou or a few tenths of a millimeter. We'll just leave that. And I don't have any interlock on this part because there's no interlocking features. There you can see the jaws have been created now. And then my next step would be to examine those, and you can see on all those hexagons the corner relief drill size showing up. So then I can set those up to be machined and used as to hold my body. So when I have to machine off that top hat on Op2, I've got a really secure method of holding it. Now this example is a little bit of a additional way to use the Softjaw Designer for holding, creating a fixture or a frame for a 3-axis part. So if we look at our geometry here in the setup of this motorcycle clutch lever, we want to look at the stock size, and we're going to use some of these values when we go back into our jaw geometry. So we're going to basically create a use one of the soft jaw sides. So normally it creates two. We're just going to use one of them as our frame. So I need to get that height value there, almost 20 millimeters. And just worth noting that currently the software designer works in millimeters. We are going to be putting out a version that works in any unit very shortly. So I'll go to the software designer and I'm going to create that body. So I want the part. And again, I'm not picking the jaws, but I'm picking the spindle direction and opening directions. So it's going to open sort of top to bottom. And I'm going to use those parameters that I looked at earlier from the stock setup to give a bit of padding on the length and width. And then the height, I want that to be the 19.619 that I pulled in from the stock size. That number is also going to come into the position. I'm going to put that in as my Z value so that the part will basically be nestled within the volume of the jaw. And then my corner relief drill size, I can again use my preferred value there. And then the all-around clearance, this is going to be my tool clearance around the part overall. So I can see I've got that created now. I've got a little bit of a whisper of a bit of material there. On the top jaw, I'm not really going to use that part, so I'm going to come in there and find it and take that off. We could either hide it, or in this case, I'm just going to delete it right off. Go to the bodies, find the relative part that I need, and I'm going to delete that off. So now I've got a starting body that I can use for my frame for my 3+2 part. I'm going to do a little bit of modification on that part using the design tools in Fusion, mostly push-pull. I'm not doing things super numerically tight. In this case, I'm just using some more visual scanning on part of the design to accommodate the fixtures that I'm going to create here. All right, so now we've got our part and a frame with the gap. The gap between the part and the frame is the all-around clearance value that we used in the Soft Designer. Again, I'm just going to use that push-pull tool to get rid of a little bit of extra material. This will help cut down my machining time. Of course, this would be really dependent on our stock that we load onto the actual body in the machine. And then just in terms of how I place this in the vise, I used a tangent joint to position the vise jaws into my frame body. So now I'm just going to skip ahead a little bit in the video. This is where I was adding in some tabs. So this was just using some really basic rectangles and extrude geometry up to the body. I didn't join the tabs into the body itself, because what we're going to do in the toolpath is use the avoidance geometry setting in Cam Assist to specify those tabs and the fixture body, or the frame body, as avoidance geometry when we set up our toolpath. So now we're ready to go into Cam Assist, and we're going to pick that avoidance geometry and do our 3+2 techniques. So there's other videos available for 3+2 using Cam Assist, and this is just an example to show some of the possibilities of using the Softjaw Designer in your 3+2 operations as well. So now that we've got that all ready to go, you can show some of the toolpaths, and be sure to check out Jay's video. We should link that in the description above for more use of 3+2. Thanks for joining us today. Have a great day.